Hi everyone, welcome back to Grade 12 Maths with Mr. Simons, where we make maths easy and get you exam ready. Right, in today's lesson, we're looking at a real past exam question from paper 2, November 2024 on Euclidean geometry, right? We're looking at question 10. So every exam paper generally would have a question on the proportionality theorem. Most of the time, or basically compulsory, somewhere between your June exam, prelim exam, and final exam, we must test the proof of the proportionality theorem. Then we give you a problem on it. Right, so let's look at the problem as asked. Right, so they have question 10 there, prop theorem or proportionality theorem. So in the diagram, triangle RST is drawn. So we have RST, the big triangle is drawn. Line AB intersects RS and RT at A and B, right? Such that AB is parallel to ST. So the space between that two is even. That's what they mean when they say they are parallel. Now say prove the theorem which states that a line drawn parallel to one side of a triangle divides the other two sides proportionality. An example, RA over AS must equal RB over BT for 6 marks. Right, so sometimes we vary this mark allocation from 4 up to 6 marks, not always 6 marks. This one they've decided to give you for 6 marks. Right, so let's look at the problem. Right, as I said, pause the video here if you want to. You can take down, look at what they've asked. Attempt to do it yourself, but generally to memorize the proof. My teacher, very brilliant teacher, Mr. von Schaefer, back in the day, said we have to practice it 10 to 12 times over to get it into our heads. Yeah, we did what he said and we just continued improving. Sometimes we have to learn to trust our teachers, right? That's if they have our best interest at heart. Right, so construction, we're first going to join SB and TA, so they're SB in gold, TA there in an oceanic color, and we draw H. So we're going to draw H1 in blue there on a dotted line and H2 in a dotted line. From B perpendicular to AR and H2 from A perpendicular to RB. So 1 mark for construction. That's 1 mark for H1 and H2. Right? Now, our objective is, remember we're proving a ratio, RA over AS equal RB over BT. So to solve this, we'll always start with area. So this top triangle in red is common to both problems. At the bottom, I have a triangle there, I throw in gold, ASB. I have a triangle there, PTA, which is a half black, greenish, emerald type of color, right? And sorry there if I get the colors wrong, I'm a bit colorblind. Right, so I say area of triangle RAB, the one in red, divided by the area of ASB, the one in gold. All right, so we look at the area straight. If I take RA as the base, right, then my perpendicular height is H1. Remember, area of a triangle is half base times perpendicular height. So there half RA times H1. Right, then because my base is RA, I'm going to take AS as my base as well. Right, so the objective is we want the portions of line on the same side of the triangle. So if I'm using RA, I want AS. So there my base is AS, and again you see that triangle there. It's not a 90, but there's the perpendicular height is the same, H1. So therefore half AS times H1, which then H1 and H1 cancel, half and half cancel, and I'm left with RA over AS. On Afrikaans, if I had to put it together, it would say ras, meaning you're making noise, right? But it's RA over AS. Take note, 1 mark for the area statement, 1 mark here for multiplication and simplifying it out. No sec 8. You see, now I'm talking English and Afrikaans. My apologies. Right, now if we look at the other side, remember now I've got RA and AS. I want now RB and BT. So again, I'm going to say area triangle RAB, the top one, over area triangle BTA. Or if you want to ABT, or ATB. That one there in green or emerald. Right? So again, there's going to be half my base RB, but now my perpendicular height there you can see is H2. For this one here, I'm going to use BT as the base because I have RB as the base, BT is the base, so the bases are always on the same side. But again, that perpendicular height for that triangle would also be H2. So therefore, area of triangle RAB over area triangle ABT, half RB times H2, half BT times H2. H2 and H2 cancel, half and half cancel, so I'm left with RB over BT. So I have that two sides over each other and these two sides over each other. Right, now you see RAB and RAB is the same triangle. No? So we can say the area of this triangle equal the area of that triangle, and my reason, it's a common triangle. It's gemeenskaplik. Right? Same triangle. Right? That's how we would say in Afrikaans, gemeenskaplik. We are common. Right? But we look at area ASB, we look at area ABT. You see, these two triangles are drawn between two parallel lines. Right? So therefore, they have the same base and they would have the same height. Because AB is parallel to ST, therefore, we can now say area RAB over that must equal area RAB over area ABT. So those two areas are equal to each other, therefore RA over AS must equal RB over BT. Right? So 1 mark there for the area statement. Yeah, 1 mark for statement. 1 mark for reason. Same base and height, AB parallel to ST. And that technically is my 6 marks. 1 there on the top for construction. So sometimes we mark 1 mark here, 2 there, 3 here, and 4, 5 there. And sometimes we can only give you 1 mark there and we make the whole problem 4 marks. As I said, it's all up to the examiners. Right? So that's the proof. Go practice it. As I said, it's just getting in the habit of writing it over and over. But the trick is, when you decide to use this side as the base, then it's that base over this base. And then on the other side, that base over that base. You can't go from this base to that base. Don't make that error. Right, now let's look at the problem given. Right, so moving on to the next slide. Alright, so in this slide, they say in the diagram, O is the center of the circle. So the middle of the circle, the center, is O. Triangle PWS is drawn with PW and S on the circle. OR is perpendicular to PS, so OR there and PS is perpendicular, 90 degrees there formed. PRS is produced to T, so PRS is extended to T. SW and OT, SW and OT intersect at V, where OV and VT are in a ratio 1:4. So meaning if OV is 1, VT would be 4. If OV was 2, VT would be 8. No? That was 3. 3 times 4, VT would be 12. So that's basically what they're giving us in a ratio format. 10.2.1, they say prove with reasons that OR here to WS is in a ratio 1:2. Alright, or this here 1:2, write them over each other, it would give me 1/2, which is half. No? So technically what they are saying, OR is half the length of WS. And the second one, they want us to calculate the length of PT. So from P to T there, if ST, from S to T is 15 units for 4 marks and 5, so that's 9 marks in total they asked last year. Right? So let's solve the first one first before we go to the second one. Right? So I hope for 10.2.1 you still remember your grade 10 midpoint theorem that you were taught. Yeah, sometimes we go way back and try to catch you out with previous knowledge. That's why it's very important to always keep your books and not throw them away, because I know in grade 12 very few teachers have the time to reteach the midpoint theorem. Right, so prove with reasons that OR to WS equal 1:2. Alright, now O is the center, né? So from O to R it forms a 90 degrees. So the line from center is perpendicular to the chord PS. Alright, theorem 1. So if that's the case, we should know according to that theorem, that means then automatically that PR equal RS. So you'll see I draw two red lines there, PR, RS. Line from center, perpendicular to chord. So that means it divides that line into two equal halves. Right? OP, OWs. From any line drawn from the center to the circumference of circles form a radius. Ne? Middle to circumference, radius. So I assume you know PO must be the same length as OW. Right? So PR equal RS, PO equal OW. So they're in proportion to each other. So according to the midpoint theorem, now I can state that OR there is perpendicular, not perpendicular, is parallel to WS. My apology, OR is parallel, and automatically then that OR is half the length of WS, and my reason would be midpoint theorem. So if OR is half of that, then it automatically means if this is 1, this would be 2. So OR to WS equal 1:2. Very important you get used to the mark allocation so that you don't go take shortcuts and lose marks while writing the exam. So PR equal RS, 1 mark for that statement. Line from center perpendicular to chord, another mark for the reason. PO equal OW, radii, 1 mark for that statement. Then here 1 mark for the statement and the reason. Alright, so 1 mark for midpoint theorem, 1 mark for that statement, and just rewriting it. So conclusion, no mark there. So that is where your 5 marks were allocated. Hope you understand, hope you follow. Right, let's look at the second problem given. Now they say calculate the length of PT. So we went from P all the way to T there, if ST equal 15 units. Now remember in the beginning they gave OV to OT equal 1:4 there. So I've drawn from O to V is 1, V to T is 4. Take note, no units, it's not 1 centimeter or 1 meter, they just in a ratio, 1:4. Normally you would say 1K, 4K or 1M, 4M. Right? Now from the midpoint theorem, remember now what I said in the previous slide, OR is parallel to WS, midpoint theorem. So this line is parallel to that line. So if they are parallel, see they have drawn ROTS, then forms basically a triangle where we have a line SV that is parallel to RO and therefore divides RS over ST and OV over VT in equal proportions according to the proportionality theorem. I hope you can see that in the drawing there. In that I think it's rose gold if I'm not mistaken. Right, so I can say OV over VT. Short over long must equal short over long. So OV over VT must equal RS over ST. Right? So therefore 1 is 1/4. In short, instead of writing out the word proportionality theorem, we just say prop theorem in short. We must specify that OR is parallel to WS. Otherwise that whole reason is not valid. So for my statement and reason, 1 mark. Right? So now they've given us that ST equal 15 units. So RS, I'm looking for RS, that piece there. So ST is 15. So RS over 15 equal 1/4. 15 times 1 gives me 15, right, over 4. Right? So 15 times 1/4, I might just leave it as 15/4. If you want to, you can see, let's see, 3 would give me 12. So 3,75 if you want to write it like that. Alright. Now in short, Remember, PR equal RS. That was from the previous slide. Line from center perpendicular to chord. Alright, so they are equal. They both are 15 over 4 units. Line from center perpendicular to chord. So PT equal PR plus RS plus ST. So 15 over 4 plus 15 over 4 plus 15. That would give me 30 over 4. Alright, 4 goes in there, 7,5. So 7,5 plus 15 would then give me 22,5 units. Alright, so then again, as I said, get used to 1 mark for statement and reason. 1 mark here for the statement. Another mark there for statement. And final mark for answer. So that's your proportionality theorem problem. Alright, as I said, practice as many past exam questions as possible. And you see, if I do the other exam question, there will also be a question on proportionality theorem. Right, so I'll be loading them up as separate questions under Euclidean geometry. Get in the habit of practicing them together. So if you decide today I'm doing proportionality theorem, go practice all the proportionality theorem problems together. If you decide you're just doing theorem 1 to 6 problems, go practice the theorem to 1 to 6 problems till you get it in your head. The same would apply to your tangent problems, your similarity problems, right? And our riders that we will get to later on. Right? I wish you nothing but the best. God bless. Bye.